Honestly, it's pretty nuts. It's almost a comical level of sustain. But one of the coolest things about this is actually under this little switch here. Check this out. Inside this pedal is a tiny $3 microphone circuit, and it's not even meant for guitar at all. I actually bought this to modify it into a proper compressor, but it literally fought me the entire way. When I finally got it working, it turned into something that I didn't expect at all. So in this video, I'm going to show you how to turn one of these into something that sounds and more importantly feels amazing. So this little PCB is designed for microphones, not guitars. It's got a built-in compressor and a noise gate, and everything about it is set up for a much lower signal level. So when you plug a guitar into it, you're basically pushing it way harder than it was ever designed for, and that's where things get interesting. The compressor is really grabby and it kind of locks into your playing. It's not transparent, but it feels great under the fingers. And the gate is honestly one of the best parts. It's super fast and it's really natural. You actually barely notice it working. The output of this thing is huge. It'll easily drive the front end of pretty much any amplifier. Now the cool part is you can easily build this for yourself. I'm going to show you the exact version that works because getting there was not that straightforward. I'm going to give you a quick overview of how this thing works. It's basically a booster with a crazy amount of compression that feels amazing and an incredibly good noise gate. Here's my dry signal. This is it engaged with the lowest amount of compression and just pushing that front end. The cool thing about the compression on this, it goes from really minimal compression up to a sort of almost comical amount of sustain. So I'm going to play really quietly here, use some dynamics. Watch what happens when I crank this compression up. So I'm going to play quiet again, then loud. It pretty much levels everything completely out and you get crazy levels of sustain. You can pretty much just keep going forever on a single note. It kind of feels a bit like cheating. It makes the guitar feel so much easier to play. Incredible amount of boost. You can really drive your amp here. If I turn it off, and this is me really slamming it. So that's the same exact setting there on my amp, just getting driven by this booster. One of the coolest parts of this is the noise gate. So the gate is always engaged. And if I play really quietly here, you'll be able to hear it doing its thing. And at maximum setting, it's killing those notes pretty quick. But it means you get this real fast, sort of snappy gate that doesn't sound choppy. Have a listen. Amazing, man. It is an incredibly, incredibly good studio grade, I would say, noise gate. Okay, so here's basically all the parts you need. There's not a lot here. There's a switch, there's some jacks, some pots, a few bits and pieces in enclosure. The main thing here is this PCB. That one is doing the majority of the heavy lifting here. Almost everything is done for you. We've just got to put it together. So I'm going to show you how to modify that PCB right now. So this is where things get a bit interesting. I'll walk you through exactly what I changed to make this work for guitar. Now, if you need a full layout and all the mod notes, I've got that up on my fourth wall, but honestly, you can just follow along here and you should be sweet as. Okay, so let's do these modifications. Okay, first things first, you need to find R1, and that's right here. So we need to remove that. Make sure your soldering iron is nice and hot. Put a bit of solder either side of that component and just go back and forth until it pops off. Just so you know, R1 was limiting the gate response, so we need to remove it so we've got full control over that gate. R2 here is limiting the compression response. So we need to do the same thing. We need to remove R2, which is right here. Next, we're removing R3. This is a 10K resistor at the output. We don't need it because we're going to be installing a pot. Beautiful. The last thing to remove is C2. That's this cap down here. This one affects the gate speed and the compression as well. Okay, I'm going to clean up these pads. So all those other spots remain empty apart from C2. We're going to be putting a 2.2 UF capacitor in that position. Just like that. Right, so you will notice that one side is negative and one side is positive. You want the negative side facing towards C5 here. So this leg has to be negative. Okay, let's wire up those pots now. Let's do the gate first. So this is your 5K linear pot. So you're going to go from this spot here to here on your pot, and then from this spot here to the center lug on your pot. Okay, let's do the compression now. So 100K audio taper pot. Same sort of thing, you're going to go from the center here, but this time you're going to go to the middle lug here, and then from here you're going to go to this lug here on your pot. Okay, so find the spot that says out, there's a little plus there, and that's going to go to the input side of your volume pot, the 10K audio pot. That's this side here. This side of your pot is going to go to ground just like normal, and this is your output that's going to go back to your switch. Right, let's deal with that input side now. So there'll be a spot labeled in on the plus. You're just going to wire in one leg of a 10 nanofarad capacitor, and the other side of that leg you're going to put a wire on that'll go to your switch. Now that puts that 10 nanofarad in series with the 100 nanofarad input capacitor, and that will drop that down to 9.1-ish nanofarads, and that's kind of where we want to be. The current input capacitor is too large, and you're just going to get a lot of clipping and a lot of early compression. Right, let's have a look at the power now. This unit here needs 5 volts to run. It can't run off your standard 9, but that's really simple. All you need is one of these LM7805 regulators. That is the guy right there. These are great to use because they just give you a perfect 5 volts. You don't really have to worry about anything. You've got 9 volts coming into this leg here. This center leg goes to ground, which is also connected to this tab at the back. If you want to chassis mount that, it's absolutely fine. And this leg here connects directly to the plus on the VCC. The negative leg there goes to the negative rail, or the center leg here. I actually put my polarity protection circuit, that free one, on our website leading into this. So that's a diode and then a capacitor to ground, just to help with some filtering. You don't need any additional filtering on the side. The circuit's already got some of that built in. So now it's just a matter of wiring it up inside an enclosure. Okay, here's my test enclosure. I've pulled this thing in and out of here a few times. I should have probably breadboarded it, but anyway, it's a little messy, but this is basically how it should look. I've got my gate pot under here. There's my wires from my gate control going under here. There's my compression pot. There's the wires, the 2 wires going there. And that's my output to my output pot here, going back to the switch. So the switch is the standard wiring that I've got on my website for a 3-pole double throw switch, that low noise standard wiring. That is my polarity protection circuit and filter circuit that I've got on my website. I've got that diode going directly to my regulator, which is just tucked around here, as you can see on the side there. It's going to the input side of that regulator. Then I've got this 220 microfarad capacitor going to ground from the output side of that diode, or the cathode side of the diode. Then the center lug on this regulator is going to ground. I'm using this ground lug here on this jack. So from my DC power socket, the ground is also going here. So that way all the grounds are tied together. It's all tied through the chassis as well. And then the output side of the regulator is just going to the VCC plus. So it's very, very simple. It doesn't take up hardly any space. You could even build this inside a guitar. It would be just the most craziest sounding guitar ever. I think it would be fantastic. If you've never built a pedal before, this is a great one to start on because most of it is done. There's very few parts you need to add, and there's not a lot of soldering or wiring. You can whip these up pretty quick. So definitely have a crack. One thing to note is the input impedance is quite low, around 100K. So you can run a buffer before it, like a Boss pedal or a tuner, or you can even build one as well. But honestly, straight in sounds great too. It just takes a little bit of that top edge off in a really sort of natural way. Also, if you're running really hot pickups and you do hear a little bit of harsh clipping, you can tame that with a 220K resistor in series with the input cap. But that really depends on how your amp is set up. The way I run amps, I doubt I'd even notice it. Now, this is one of those projects that's a bit different. It's not perfect and it's not super clean, but it's just really addictive to play through. And that's the cool part. You're probably not going to be able to hear anything else out there like this. If you end up building one of these, let me know down in the comments. I'd be really keen to hear what you think. Anyway, guys, have a great week. We'll catch you in the next one.